Okay. Hello, good afternoon, fellow students. It's your usual online physics teacher. Today we'll be talking about gas laws. Gas laws. And in dealing with gas laws, we'll be dealing with about three to four personalities. We have one of these scientists called Wells. Under gas laws, Wells said, Boyle's law stated that the volume of a given mass, the volume of a given mass of gas is inversely proportional to its pressure. The volume of a given mass of gas is inversely proportional to its pressure at constant temperature. At constant temperature. And what this implies is that you introduce your constant of proportionality, V is equal to K over P. This is the implication. Or, you can find K, but K is equal to PV, which is the same thing as P1 V1 is equal to P2 V2, where P1 and V1 are initial pressure and volume, where P2 V2 are final pressure and volume. Let's take note of that. This is what Wells is saying. Wells is saying that for a given mass of gas, the volume is inversely proportional to its pressure at constant temperature. And this is the representation. So in the arithmetics, we will be dealing with P1 V1, P2 V2. So from Wells' law, we have Charles' law. We have Charles' law. But Charles said that for a given mass of gas, the volume is directly proportional to its temperature at constant pressure. So this is what Charles is saying. So we have to introduce our concept of proportionality. So we say V is equal to Kt, where K is constant. K is constant. So in finding the constant here, we can just divide both sides by T. So you have K is equal to V over T. So we can also say that V1 over T1 is equal to V2 over T2, where V1, T1 are initial volumes and temperature, and V2, T2 are also final volume and final temperature. So take note of this expression, very important. Also take note of this Boyle's expression, very important. So from Boyle's law, it came to Charles' law. Then we have Avogadro's law. Avogadro's law. Avogadro stated that the volume is directly proportional to the amount of substance, that is N, where N is the amount of substance. So Avogadro is saying that the volume is directly proportional to N, where N is the amount of substances. So when you take Boyle's law, Charles' law, and Avogadro's law to form and you add them, you will get what we call the ideal gas. The ideal gas. The ideal gas. Because we are saying the gas is ideal because when a gas obeys all the three gas laws, this now we are going to as we were talking about the ideal gas equation. So an ideal gas is a gas that obeys all the gas laws. So ideal gas is a hypothetical that obeys the gas laws. So in the ideal gas equation, so in getting the ideal gas equation, we take the Wells law, the Charles and the Avogadro's law. So from Wells, pause, pause. From Wells law, so from Wells law, we said the volume is inversely proportional to the pressure, but Charles law stated that the volume is directly proportional to temperature. But Avogadro's is saying the volume is directly proportional to the amount of substance. So we are using the three laws to get the ideal gas equation. So now what you can say is that all of them, they are either inversely proportional to pressure or directly proportional. There's a proportionality constant here. So you can see that V is common. So we write V volume. So now all after the proportionality, you could see that all of them are inverse to the pressure. So time and amount of substance will come here. So we have amount of substance over P. But we have to introduce our constant of proportionality. So when you are introducing the constant of proportionality, uh, here we use R as constant. R is the constant. So V is equal to R N T all over P, or V is equal to N R T all over P. It's the same thing. Multiplication is commutative. That is to say, 2 times 3 is equal to 6, and 3 times 2 is equal to 6. So it's the same thing. Either RNT or NRT is the same thing. Multiplication is commutative. So we have to find this. We say V is equal to nRT all over P, but we have to get factorize this. So we have P, we go with P, where we have our PV is equal to nRT. That is the ideal gas equation. So this is the ideal gas equation. So this is how you can derive the ideal gas equation. So I'll give you an example where we will solve the question relating all these gases. Yes. So this is a practical example of a question under the gas laws. So we can get a question like this: a given mass of calcium carbonate, is heated and 350 centimeters cube of carbon dioxide is collected at a temperature of 29 K Kelvin and pressure of 110 kilonewton meters square. Write a balanced equation of the reaction. That's question 1. And the II says that we should calculate the amount of moles of carbon dioxide. Then III is saying that we should find the mass of calcium carbonate. So they've given us the mass numbers. We have carbon, oxygen, calcium, and then the constant of proportionality R is given. So when a question is asked like this, you come and first find out from the first question. They are saying that we should write a balanced equation of the reaction. So when you are writing a balanced equation, it means that you have to consider those that are reacting to produce something. It means that something will be cooked. You have to cook something to get something. So what is being reacted here, or what are the reactants? In every balanced equation, we are dealing with reactants and products. Reactants and then what? Products. So now you ask yourself, what are the reactants here? They said a given mass of calcium carbonate was heated. It means that calcium carbonate was heated, so that becomes the reactant. So calcium carbonate was heated to give. They say it was heated to calcium carbonate is heated, and then carbon 4 oxide was collected. Carbon 4 oxide was collected. This is carbon 4 oxide. This gas that was collected. So meaning when you heat this and you collect carbon 4 oxide, what will remain? So watch here. So let's assume this is the carbon 4 oxide that was collected. But remember that we have carbon here, one, we have oxygen here, two, meaning that calcium will remain, and then one of the oxygen two will remain. So you have calcium oxide remaining like this. Hope I'm clear with you. Good. But so this is how the resulting product was formed. So this reacted to give you this product. So this is the sample balance equation for I. You can also say is for I. So come the equation is balanced. Calcium here is 1. Calcium here is 1. Carbon here is 1. Carbon here is 1. Oxygen here is 3. Oxygen here is 2 here plus 1 here, making it 3. So the equation is balanced. The equation is what? Balanced. The equation is balanced. So now we come here. Calculate the amount of moles of carbon 4 oxide. II. Amount of moles of carbon of carbon 4 oxide. So now they are saying to find moles. So now you come to the question and see what has been given so that you can know the formula that you can use to find it. So in the question, they gave us a volume to be 350. They gave us a V to be 350 centimeters cube. They gave us pressure. They gave us temperature to be 29 K. They gave us temperature to be 29 K. They gave us pressure to be 11. They gave us pressure to be 110 kilonewton meter square. You get it? So what you can see, the relation here is that you can see that in the ideal gas equation, we set PV from ideal gas. We set PV is equal to nRT. Where P is pressure is given. Where V is volume is given. Where T is temperature, T is given. Then constant of proportionality, which we have it here. So we mean that we don't know amount of substance, and so amount of substance that we are going to find. So you now say you divide both sides by RT, where temperature will be temperature, constant will be constant, leaving amount of number of moles or amount of substance is equal to PV over RT. PV is equal to where PV over RT is equal to moles, where this one is moles. So our pressure is given to be 110 times our volume is given to be 350 Then our constant of proportionality is given to be 8.314. Then our temperature is also given. Our temperature is given to be 298. 298. So Kelvin. So now when you divide both all of this, when you multiply this, take the product of this, then you take the product of this, then you divide. You see that you get 0.0155 mole. Finding mass of calcium carbonate. Finding mass of calcium carbonate. So, in one of our formulas, we learned that mole is equal to mass over molar mass. But to find our mass means we get mass is equal to mole times molar mass. But our mole is equal to 0.0155 mole. But our molar mass, we don't know. So that means we have to find the molar mass for calcium carbonate, molar mass of calcium carbonate, which is equal to calcium, the mass number is 40 plus the mass number for carbon is 12, the mass number for oxygen is 16, is multiplying 3 molecules by 3. So if you take the sum and multiplication, you get 100 grams per mole. So coming to the formula, our mass is equal to mole 0.0155, the product of 100 grams per mole. Then use your calculator and see what you get. So you are likely to get 1.55 grams. As therefore mass mass of calcium carbonate is equal to 1.55 grams. Thank you. Yeah, so basically today this is what we have learned about gas laws. So I want you to subscribe to my YouTube channel on Lab Sari YouTube, and then the Facebook is Sari. Thank you.